Welcome to another training video presented by the Nobius Training Group. Today we're going to be talking about configuring and verifying basic IPv6 Access Control List, or ACLs. Being familiar with IPv4, you would already know that standard ACLs are placed nearest to the destination based upon the source address only. Extended ACLs are placed nearest to the source to alleviate any unnecessary bandwidth consumption by packets traversing the network toward the destination, and you can filter by protocol and port number, for example www or FTP. Some things to keep in mind about IPv6 access control lists is that in IPv6 there are only named ACLs, not numbered lists like most IPv4 ACLs. Their configuration syntax is similar to that of an IPv4 extended named access list. The most significant difference is that IPv6 ACLs use a prefix length instead of the wildcard mask like IPv4. Another major difference between IPv6 and IPv4 ACLs are the three invisible ACE statements at the bottom. ACE stands for Access Control List Entry. They permit ICMP any, ND, and A. That's for any network to any other network, network discovery, neighbor advertisement. Permit ICMP any, ND, and S. That's network discovery, neighbor solicitation. Then, of course, the implied deny IPv6 any at the very bottom. These two permit statements are required for neighbor discovery, which is an important protocol in IPv6. This is the replacement for ARP, Address Resolution Protocol, which you know can be spoofed. IPv4 access lists have the invisible implicit deny any at the bottom of every access control list. Unlike IPv4 ACLs, there is no option for standard or extended. IPv6 ACLs are basically extended because you want to be as detailed and granular in your network control as possible. So like extended ACLs in IPv4, you want to place them as close to the source of the packet as possible to eliminate unnecessary bandwidth consumption by packages traversing the network. There are four simple steps to configure an IPv6 ACL. Step 1. Enter the command IPv6 access-list, then name, and then create the access list. Bear in mind that IPv6 named lists are alphanumeric, case sensitive, and most importantly, unique. Capitalization is not required, but it does make them stand out when viewing the output of the show running configuration. So it makes it the most preferred method when you're looking for it. They stand out. Case sensitive, you can have two access lists named exactly the same way, but one in uppercase, one in lowercase, or a mixture of the two, and that would make it more confusing. So that's why we try and capitalize the access control list name so it stands out and you can tell that it's unique. Here's an example. IPv6 access-list, and then all caps block _ PC1 _ HTTP. Now put a remark in there, hey, this is all caps versus no caps. The very next access list I created is IPv6 access-list, and then all lowercase block _ PC1 _ HTTP. The remark, same name, no caps, but this is a different ACL. So if you had two of them named the same, or would look like the same, hey, they're different. One is uppercase, one is lowercase, because they are case sensitive. Step 2. From the config IPv6-ACL prompt, you use the permit or deny statement to specify one or more conditions that will determine if the packet will be forwarded or dropped. Notice that the prompt is config IPv6-ACL, not config-IPv6 ACL, like it would be if it was a IPv4 access list that said config extended NACL for a named access control list. Being that they're all named in IPv6, you'll never see it say NACL. Step 3. Apply the ACL to the proper interface and in the appropriate direction. Use the command IPv6 traffic-filter and the name of the ACL, and then inbound or outbound. If you remember IPv4, it was what? Access group. Step 4. Type end to return to the privileged exec mode. Creating an IPv6 ACL for a single host. In this example, I'll be using the global addresses of 2021 : Foxtrot Alpha Charlie Echo : 2 : Bravo 00 Bravo : /64 and 2021 : Bravo 00 Bravo : 2 : Foxtrot Alpha Charlie Echo : /64 as the source network and the destination network. The goal is to block PC2 from right over here on the left from HTTP accessing that web server off of router 2, but allow it to go HTTPS. The planning considerations, how to write it. The best practice is to write out the complete command syntax of all the access control list entries you want to do on a piece of paper and have someone else look at it to see if you might have missed anything, especially when you're configuring multiple entries on an ACL or multiple different ACLs that are going to go on a router. But we're going to keep it safe here and simple. Here's an example. Router 1, config IPv6 access -list block PC2 HTTP. Then the prompt changes to config-IPv6 -ACL. Notice it does not say -NACL. We're going to deny TCP, the host, and the address of PC2, the destination host, and then the address of the server. The little EQ there, it can be EQ, NEQ for not equal to, greater than, less than. That is the operator portion of the syntax for an access control list. Then, of course, the port or protocol, which in this case is www or port 80. Where to place it? If you draw out your map of your network, you draw arrows in the direction of the packets that would take from the source to the destination, so you know where is the best place to apply that ACL. Some questions to keep in mind though. Do you have control over the router where the ACL should be applied? If you don't, then you're going to have to compensate for that and maybe put the ACL in 1 or 2 different locations in 2 other routers. Are there multiple different paths to get to that destination? So we go to router 1, we config interface gigabit 0/0/0, that is the inbound LAN port. We type in IPv6 traffic filter and the name of that access control list that we typed in, block _PC_2 _HTTP in on the inbound. And that will basically force this router to perform all the filtering before any of that HTTP traffic going to that web server. It'll block it right there. If it goes through HTTPS, then it will allow it through and let those packets traverse the network. Remember, we apply it closer to the source to try and eliminate all unnecessary traffic on the network. How to test it? Well, you attempt to access the web page on the web server from both the PCs using HTTP. PC1 should have access, PC2 should not. Both should be able to access via HTTPS. And when we do this, we'll go into Packet Tracer and view this. Let's do it. Alright, we've moved into Packet Tracer. We can see I've got my network built. We're going to start in, and we're going to use the block PC2 from accessing the web server there off of router 2. So we have to do our IPv6 access control list that will block HTTP but allow HTTPS only. So we're going to go into router 1, go to the CLI mode, go into global config, and we're going to type in IPv6 access list. You hit your tab key, it automatically fills it out for you. This is where your IPv6 name is going to be case sensitive, and we said we're going to use all caps because it makes it stand out easier. So we're going to go block _ HTTP. Actually, we're going to go back here. We're going to go block PC2 _ HTTP. That's all we're going to call it. Next, we are going to deny because we're blocking. So we're going to deny only PC2 so we can use host, and then the actual address of PC number 2 for that network is 2021 : face : 2 : Bravo 0B colon, and then his address. So we'll do another colon, and then he is :69. Just like that. That's his address. Then we got to say the destination address, which is over on the server, which is host 2021 : Bravo 00 Bravo : 2 : and his address is 3. Then we got to do the operator statement, EQ, and we're going to go www. You can also do port 80. Okay, it doesn't like something there. Let's see what I did wrong. Stretch it out here. Oh, I forgot to put the word TCP in there. Silly me. What are we denying? We are denying TCP for that actual port. So I back it up here and fix that. I'm not a perfect typist. I get ahead of myself. But there, now it's happy. After this, remember, there's implicit denial at the very, very end. So we have to go in and permit any other IPv6. So we're going to permit IPv6, any source, any destination. That's everywhere else. That's it. It's done. We exit out of this. Now we go in and we apply it. We're going to apply it on the gigabit 000 interface and block it on the inbound port. So it blocks PC2, but it'll still allow PC1 to go through HTTP. And we're going to demonstrate that in a moment. So we're going to interface gigabit 0/0/0. If you don't know what your port numbers are on your router that you're using, you can always do a show IP interface brief, and it will give you a list of all the interfaces on that router, so you know how to number them accordingly. Some routers have only 1 gigabit 0 port, some have fast Ethernet, some have gigabit 0/0. But I'm going to stop on that. So now we got to go IPv6 and its traffic filter, and then we got to have it exactly the same. Block _PC2 _HTTP, and it's case sensitive. I did one earlier to where I screwed up and I had HTTP when I meant to type HTTPS and I couldn't figure out why my access control list didn't work. Duh, it was me typing wrong. So we're going to do this correctly. And we're going to apply it on the inbound interface because the packets are coming in inbound to router 1 to go out. Control Z, and I'm going to go ahead and write that configuration to my router so I don't lose it. Close that down, and we'll get on PC2 and make sure it can not get to the web server. Go to PC, go to Desktop tab, Web Browser, and I've got DNS enabled so it'd be easy enough to do this. So I can just go in here and go HTTP : and I called mine packettracer.com. And this would tell me, hey, hostname unresolved. Oh, well, yeah, if you got to put a COM on there. I got typing too fast. But we go back over here and we change that to HTTPS. Hey, it comes up. Let's change it back to HTTP. And it should say, sorry, ain't there. May not resolve it. Let's see. Let's try it again here. We'll just go pt.com because that should force it to go through like that. And it should come up, say, timed out. We'll give it a moment. Requested timed out. It just didn't get there. We go back and we put the S on there to go through port 443, and we got our web page. Close this down. Let's go over to PC1. Go to its desktop tab, web browser, and we're going to type in there pt.com, and it should come right up. Look at there, because it is going through HTTP, not just HTTPS. We can of course go HTTPS, but the access control list is only blocking PC2. Creating an IPv6 access control list for a network. The planning considerations are exactly the same, only the configuration is slightly different. Here, we're going to block not only the PCs on router 1, but also from anywhere and everywhere else from accessing anything on that financial server except HTTPS. We're going to put our access list in router 3. Why? Because you have a path from router 1 to router 3. You have one from router 1 to router 2 to router 3. You could go router 2 to router 1 to router 3, or router 2 to router 3 directly. You want to be able to put it in the router, and you're going to apply it to the interface that's going to protect against all those other possible routes that we see. So our access list is going to be IPv6 access-list permit underscore HTTP underscore only. That's all we are allowing. The configuration statement says permit TCP from anywhere, that's any, to the host at 2021 : Bravo Echo Echo Fox : Alpha Charlie Alpha Delta : Bravo 0 Bravo. That is the IPv6 address of that server that's right there. Then you have the operator statement, which is EQ or equal to. Remember, we have the equal, not equal, greater than, less than. We're not getting into all that here because we're keeping it simple. And then 443 is the port number for HTTPS. That's our only statement that we need. We're not going to permit anything else, and everything else is going to be implicitly denied. We're going to exit. Then we're going to jump into our interface, and we're going to interface gigabit 0/0/0. That's the LAN leg going out to that financial server. And we're going to apply that access list, IPv6 traffic filter permit underscore HTTP only, out. Then we end, and it takes us right back to the router 3 prompt. Of course, you'll want to test this and then save it into your running configuration. So let's go configure it. Alright, for our second IPv6 access list demonstration, we're going to be over here off of this router 3, and we're going to prevent anybody from going to this financial server, this bank server, bank.com, from going HTTP. We're going to force them to go HTTPS only, because obviously you don't want anybody getting your banking information, and you want it to go through as secure as possible. So we're going to go through that. We want to prevent anybody, that means PC1, PC2, the web servers, any of them, or even this router, from doing anything to this financial server that is not over port 443. So we're going to go into router 3 here, go to our command line. Let's get this thing here to access it there. Of course, enable. I don't have a password on my router. Oh, wow. We're going to type in IPv6 access list, and we're just going to simply call it permit underscore HTTPS underscore only. Now that we're in our access list, we can put in what we want to do. So we go permit TCP, didn't forget my protocol that time, any host, any address out there to the host of that server, which is 2021 : beef : acad : Bravo 0 Bravo. And we give our operator statement, equal to, not equal to, less than, greater than. We're going to go equal to, and we're going to put the 443 in there. Once again, oh wow, I put host off. Wow, really? I must have been typing what I was saying. There we are. How about that? It likes that one. And now we don't have to do anything else, because everything else will be denied at the end of that access list, aside from network discovery and network advertisements, all the good stuff like that. So this is all we need to do. So we exit it, and now we move this out of the way here. Where are we going to put this access list? On this serial interface here coming in? On this one coming in? No, we're going to put it on the LAN interface going out, because we have multiple sources, multiple paths of how to get into that router. So we're going to apply it on the gigabit interface going out. So I'm going to go interface gigabit 0/0/0. Whoop, yeah, I can't type today. And now we'll go IPv6 traffic filter permit HTTPS only in the outbound direction. And I'm going to write that to our configuration, save it just like that, close this down, and now come over here, open this up. We're going to go www.bank.com, and it should time out because it's not allowed to go through HTTPS. And there you have it. Now we're going to come over here, HTTPS, say, oh, wow, that was easy because that PC2 you already had access list. Well, let's jump on PC1. Here we had it. We're going to go through and refresh it, and it should time out. It may not because Packet Tracer may not refresh the screen, but we'll find out. We'll go through here. We'll do it again this way. That way it forces it to clear it. It's a lot easier doing it with a URL and an address than it is an IPv6 address. This guy's going to time out. There you go. Put the S in there and look, it comes up. It's happy. And that concludes this lesson on IPv6 Access Control Lists.